All right. We are going to jump into lesson 5, which is dimensional analysis. And dimensional analysis, super long story short, is all about um, how we convert between uh, given units and unknown units, or like, for example, meters and centimeters. And we're going to talk a little bit about how to do that. And we're going to do a couple of example problems. And this lesson is going to occur over the course of 2 days. So I'm going to break it up into 2 videos. All right. So you should have a note sheet in front of you that looks a little something like this. And as a result of that, we're going to go through and just kind of fill in some notes and talk about a few things. Okay, so dimensional analysis is a fancy way for converting unit to say is a fancy way to say converting units. And so the first thing we have to do is talk about how we find a conversion factor. And a conversion factor is simply a ratio used to convert from one unit to another. It's made when two measurements are of the same value. So we know from like a ruler that 1 foot is equal to 12 inches. And hopefully, what we would think is that if this is the distance of 1 foot, this is also the distance of 12 inches. And so that's what makes them the same, is that they're equal to one another. So there's this generic template right here. This generic template for converting between units is like the backbone of how we do it. It's going to be a couple of fractions, and it might look a little bit complicated, but it's not as complex as it looks. So what I want to talk about next, or what I want to say next, is that the units in these problems act like variables in math class. And so if you were in math class and you had this expression right here, um, and so if I were you, I would write like maybe I kind of fill this in like right here in your note sheet. Okay. Um, so if you were in math class, you know this expression A times B times C over A times C, and you were asked to simplify that, what would you do? Well, most of us would look at that and say, "Oh, I see there's an A up on top, and I see there's an A up on the bottom. So I'm going to just simply go ahead and I'm going to divide the A's out. So I'm going to cancel the A's out. I also see that there's a C on top and a C on the bottom, so I'm going to divide the C's out. And so my final answer here, once this is simplified, is simply going to be the variable B. Now, in this class, we're not going to be using variables as much as we are going to be using units. And the units could be things like inches or feet or centimeters or meters. Okay. And so we're going to jump into and do an example of how that works now. So dimensional analysis is really this method to organize how we convert things. Okay. And so what's important about that is that okay. Um, hold on. I'm going to pause here and try to figure out what. All right. I'm not sure what this is in the lower right hand corner, but we're just going to move forward. So, in dimensional analysis, there's a few things that we have to do. And as far as our notes go, if you're looking at your note sheet and your note sheet is sitting right in front of you, on the left hand side of your chemistry notebook, on page 18, I want you to actually do this conversion factor with me. So, let me go grab my notebook real quick because I want to show you that. So on page 18, so here's my notebook. At some point, you're going to glue the note sheet onto page 19. And on page 18, you're going to do these problems with me. So if this is the convert 635 or 32.5 inches to feet, we're going to do that directly over here in our notebook. Hopefully that makes a little bit of sense. And we're going to go forward. Okay, so there's a couple things that we need to know. We need to first of all identify what our given is. So in this case, we're going to try to figure out what's given to us in the problem. And we should probably also figure out what our unknown is. So that what that really means is, what is the problem? What are we starting with? And what is the problem asking us to solve for? So in this problem, we are starting with 632.5 inches. So that's my given, 632.5 32.5 inches, and we are going to convert it to number of feet, which is our unknown. So I'm going to say number of feet. Now, we just talked about the fact that we knew the relationship between inches and feet. We said that there are 12 inches equal to 1 foot. Okay. And so we're going to use that knowledge to help us do this conversion. So the first step for all of these conversions is to take our given, which is 632.5 inches, and I'm going to put it over 1, like so. I'm then going to go ahead and set up a conversion factor so that units of inches cancel out. So I want to put units of inches on the bottom, and I want to put units of feet on the top. And that N is really gross, so I'm going to get rid of it and fix it because I don't know what to do with that. So we're going to make that better. Inches. Now, so according to our relationship, there are 12 inches in 1 foot. And so if I do what the problem is asking me to do, or what the directions on the bottom tell me to do, which is multiply straight across the top and then multiply straight across the bottom, I'm going to take 632.5 and I'm going to multiply it times 1. So that's going to give me 632.5. Now my unit I'm going to bring across, right, is inches times feet. Okay. And if I multiply straight across the bottom, 1 times 12 is 12. And if I bring that unit across, I have the unit of inches. So at this point, I'm going to go ahead and do some math, right? And I'm going to try to cancel out anything that I can possibly cancel out unit-wise. I see that I have inches on the top and inches on the bottom, so I'm going to cancel them out. So now I'm going to take 632.5 divided by 12 on my calculator, and I'm going to get a value of 52.78, and my unit is feet. So in this problem, we converted 632.5 inches to 52.8 feet. And we showed how that is possible through the dimensional analysis process. So now, if you didn't quite get that copy down, I suggest you pause the video and copy that down on page 18 of your notebook. And now we're going to go to another scenario. So when using dimensional analysis, we use the metric system. We're looking for the relationship between the prefixes, and it appears that on your note sheet I don't have this using, and it shouldn't be there, so let's get rid of that. Okay. So when using the metric system, we must find the relationship between the prefixes, and sometimes you might have more than one conversion factor. In this case, we're going to have 2 conversion factors. Now again, I want you to go ahead and convert 235 centimeters to micrometers on page 18 of your notebook. So we'll do that now, but I want you to do it in your notebook. So the first thing that we need to do is we need to identify what our given is. So in this case, this is our given, the 2.35. And we also need to figure out what our unknown is. And in this case, we're going to go to the unit of micrometers, which is unknown in terms of a value. So now we're going to set up our relationships. So I know, and we're going to have a lot of practice with this going forward, that there are 10 centimeters in 1 meter. I also know that there are 100 micrometers, or I'm sorry, 1 million micrometers in 1 meter. And I lied. It's not 10. It's 100 centimeters in 1 meter. Oh my gosh. It's the heat. So now I'm going to set this up where my unit of centimeters cancels out. And I need to do that by putting the unit of centimeters on the bottom. And what centimeters is equal to in my relationships up above is meters. So I'm going to put meters on top. Now I see that 1 meter is equal to 100 centimeters. And if I stop doing math there, my unit of centimeters cancels out, right? But I don't want my unit of centimeters to simply cancel out and be left with meters. I want to get to micrometers. So I need to further cancel out meters. So I'm going to put meters on the bottom, and I'm going to put micrometers on the top. And micrometers, the symbol is like a U with a fancy tail off the front of it. Looks like that. So now I'm going to fill in the values. So I have 1 million micrometers inside of 1 meter. And now what I'm going to do is I'm going to try to do a little bit of math here. So we're going to go and we're going to multiply straight across the top. And so when we multiply straight across the top, you get a value here of 2.35 times 1 times 1 million. And you get 2,350,000, right? And really, in reality, you've got a couple of units you have to deal with. So we have centimeters, we have meters, and we have micrometers. Okay, and so that's going to be my top value. And when I multiply across the bottom, 1 times 100 times 100 is 100. And my units that I bring across are going to be centimeters and meters. So when I go ahead and do some division at this point, hopefully what you can see is that the units for centimeters cancel out, the units for meters cancel out, and I'm left with a unit for micrometers. So when I plug this into my calculator, I get a value of 23,500 micrometers. So that's it. That's where we're going to stop for today. And there's no homework right now. So if you do have questions about this as we go forward,